Hello guys, welcome to Primus Learning. It's Aziz here today, and we are going to be looking at AWS VPCs. Previously, we have looked at IAM and we have looked at S3. So today, let's discuss about the concept of virtual private clouds. So after moving to the AWS cloud, it's very important that we should be able to, separate our resources so that we can be able to control who can access our resources, or what traffic are we going to be letting into our resources and what traffic are we going to be letting out of our resources. So remember, AWS is very, very broad, right? AWS is very, very broad. So how can we be able to manage resource separations? How can we be able to manage resource separation? You can think of it like if you have many different applications and you want to be able to separate, make sure that whenever you have a virtual machine of this application and the virtual machine of another application, you don't want these resources to be able to communicate by default, right? So because the network is very, very big, what service is AWS giving us to be able to separate all these resources is what we call AWS VPCs. So in your AWS cloud, usually you have a region. So we have a region, and then in our AWS region, we can be able to create a VPC, and in your region you can have you can create multiple VPCs. You can create multiple VPCs like this. Say you want to do something like this to be able to separate our resources. So we have a VPC, we have another VPC here, and then we have another VPC. So when you do this, if you have now a resource, for example, if you have a virtual machine, which is what we call an EC2 instance in this VPC, and you have another one in this VPC, and you have another one in this VPC, you can be able to control how traffic is going to flow across all these various applications, and also externally from someone coming from the internet. Okay, so what exactly is a virtual private cloud? A virtual private cloud is just a way of us creating a sub network out of AWS's big network. And when it comes to VPCs, AWS says that we can create, whenever you're creating a VPC, first you need to choose what we call the VPC CIDR. The CIDR of the VPC basically is just an IPv4 or an IPv6 IP address, and it's supposed to be within with AWS permits us to use within the range /16 to /28. So you need to choose a CIDR within this particular range. Say for example, we can choose our VPC CIDR as 10.0.0.0/16 to be our VPC CIDR. So this can be our VPC CIDR. So let me go ahead and remove this one, and we can work with a single VPC. So we have a single VPC. One thing very, very important, whenever you create a VPC, your VPC spreads across across the whole region. Your VPC is going to spread across the whole region. But now, once we create our VPC, we can still be able to go ahead and separate our resources at the level of the VPC himself, right? How can we be able to do this? We need to go ahead and split the VPC CIDR into what we call sub networks, right? So we have a bigger network, which is our VPC, and then we can split up this VPC into what we call subnets. Now, when you're splitting up your subnets, you need to one thing to remember is that a subnet lives in a particular availability zone. So say for example, we have availability zones. So we have an availability zone like this up. Let's add two availability zones here. Cancel. So in our AZ, we can go ahead now and add what we call a subnet. We can add what we call a subnet. And in your subnet, you can have in your AZ, you can have multiple subnets if you want to. I want to remove this. And in a single availability zone, you can have multiple subnets. So when we take our larger VPC, we can be able to take our VPC and separate them into what we call sub networks, right? So usually VPC siders accept what we call subnetting. So you can take this sider and then you can break this down to have multiple sub networks. But because we are not actually looking at teaching subnetting in this particular series, we can go ahead and show you when we are going to be working with the hands-on section. I'm going to show you guys a very nice tool that you can use to be able to do the subnetting. So after you have your VPC sider, for example, we can see our first subnet is going to be 1.0, 1.0.1. Since we are subnetting, then this can be a /18, for example. So we can have this as the sider of one of the subnets. And then for this other subnet, we can see that this subnet is going to be like this, and we can see this subnet is going to be a 3, and so on. So you can see we have taken a bigger network and we're able to separate this network into smaller network that are called subnets. Whenever you're creating your subnets can either be public or our subnets can be private. But by default, all subnets are basically private. But how can you make your subnet public? First, how does your VPC communicate with the internet? For your VPC to communicate with the internet, you need to create what we call an internet gateway. So we need to create what we call an internet gateway, and to our VPC, we are going to attach the internet gateway. So once you have your internet gateway attached to the VPC, then your VPC can now communicate with the internet. So once we have our internet gateway, our VPC can now communicate with the internet. And now, even though our VPC is now communicating with the internet, how can you make your subnets to be able to communicate with the internet? To be able to control communication at the level of the subnet, we use what we call a route table. So we need to create a route table, and then to our route table, we are going to add a route that is pointing to the internet through the internet gateway. So to make a subnet public, you need to create what we call a route table, which is going to be associated with that particular subnet. And into our route table, we are going to add a route that is moving to the internet through the internet gateway. Once you do this, your subnet is now public. So whenever you can also have private subnets. So we can also have private subnet. So if you have your resources in your private subnet, for example, say we have a virtual machine in our private subnet, and this virtual machine needs to be able to communicate with the internet, maybe to do operating system updates, patches, and so on, then we can use what we call a NAT gateway. And then when we have our NAT gateway, we can then create a route and attach it to our private subnet. And then our private subnet is our resources in the private subnet can be able to go to the internet for operating system updates and patches by going through the NAT gateway, and the NAT gateway is then communicating with the internet gateway. If we have this, then our resources in our private subnet can be able to communicate with the internet for like operating system updates and patches whenever they are needed. So these components are very, very important. So you have your VPC. Whenever you're creating your VPC, you choose the cider block of your VPC. When you have your VPC, from your VPC, you can create what we call sub networks by doing subnetting. And now when you're creating your subnets, a subnet can either be public or it can be private. By default, your subnets are going to be private, and to make a private subnet public, you need to create a route table and associate this route table to that particular subnet, and then you're going to add a route in the route table that is pointing to the internet through the internet gateway. Then when you have your private subnet and you want your resources in your private subnet to be able to reach out to the internet for like operating system updates and patches, then we need to add a route in the private subnet that is going to be moving to the internet through the NAT gateway. And if you can notice, our NAT gateway is in the public subnet because it needs to be able to communicate with the internet. So in our route table here, we then create that communication between the NAT gateway and this internet gateway, and then with this association. So these are the basic components of what we call a virtual private cloud. Now, when you have multiple VPCs in your AWS account, you can have multiple VPCs. I'm going to skip the AWS, and then I'll just let's just add a region. So if in your region you have multiple VPCs, so we have multiple VPCs. If we have resources in these VPCs and you want these VPCs to be able to communicate with each other, if you have resources in VPC A and another resource in VPC B, and you want these resources to be able to communicate with each other, we can use what we call a VPC peering connection. You can use what we call a VPC peering connection. So with a VPC peering connection, our resources in VPC A are going to be able to communicate with our resources in VPC B. But it doesn't only end here. After that, we need to also add our routes. After that, we need to add a route. We need to add route tables and in our route tables, we now need to add the routes that are pointing to wherever we want our traffic to flow through, and then it's going to be going through the VPC peering connection. So if we do this, then we can have two VPCs be able to communicate with each other by using what we call a VPC peering connection. The only drawback with VPC peering connections is that VPC peering connections are not transitive, which means that if you have three VPCs, for example, if you have three VPCs and you have a VPC peering connection between VPC A and another one between VPC A and VPC B, and then we have another one between VPC B and between VPC A and VPC C, then it doesn't mean that VPC C can automatically communicate with VPC B. It doesn't work that way. You also need to exclusively create another route, another VPC peering connection between VPC C and VPC B. So VPC peering doesn't support transitive peering connections. At the level of our subnets, we can be able to control traffic. To be able to control traffic, what type of traffic are we going to let into our subnet, and are we going to let out of our subnet by using what we call network access controllers. So a network access controller is basically just a couple of routes we are going to define and say, for example, we want to allow HTTP or HTTPS traffic, and then we can set what we call NACL roles, right? So in the hands-on section, we are going to see exclusively what we call network access controllers, and we are going to create network access controllers. So apart from VPC peering connections, we also have what we call transit gateways, right? With transit gateways, you can be able to create peering connections between multiple VPCs also. And transit gateways generally are used when you have much more bigger networks, or when you have lots of VPCs that need to communicate. Then you can go the transit gateway route. But VPC peering is good if you don't have too many VPCs to do the peering. When working with our VPCs, we can also be able to ensure that resources in our VPC can be able to communicate with resources out of our VPC. So if you want resources within your VPC to be able to communicate with resources that are out of your VPC, you can be able to use what we call a VPC endpoint. You can use a VPC endpoint. With a VPC endpoint, we can be able to ensure communication between resources that are inside our VPC with resources that are not within our VPC. For example, you can create a VPC endpoint between your resources in your VPC, and say, for example, another AWS service like S3. So a VPC endpoint is another service of VPCs that you can use to be able to ensure communication between resources that are inside your VPC and resources that are out of your VPC. That's all about AWS VPCs, and I'll see you in the next lecture, where we're going to do the hands-on part on creating AWS VPCs and our subnets, and do the various communications between our AWS VPC and its resources. So I'll see you in the next lecture.